Here is our problem. As you can see in the picture that there is a large number of sticks and discs, and it is given that the mass density per unit length of stick is rho, and the radius of the disc is r. The sticks and discs are leaning on each other, as you can see in the picture, and it is given that each sticks makes an angle theta with the horizontal and is tangent to the next disc at its upper end. Also, as you can see in the picture that the sticks are hinged to the ground, and it is said that all the surfaces are frictionless. Now, let the normal forces at the disc stick contact from the left as N1, N2 and N3 and so on. And also, as we can see in the picture that the last disc leans against a wall to keep it from moving, that is to keep the system is in equilibrium. In the limit of a very large number of sticks and discs, what is the normal force between a stick and the disc? It rests on very far to the right. That is, we have to calculate the n infinity. Here is our solution. This picture is given for the clear geometrical understanding, and in this picture, in triangle OAB and triangle OAD, this is triangle OAB and triangle OAD. We can see that the length of AB is equal to AD. This is the property of the tangent, and also the length OB is equal to OD. This is the radius of the disc, and OA is the common line. So we can say that the triangle OAB and triangle OAD are congruent. It means the angle BAO is equal to angle OAD. This is the half of the angle BAD, that is theta by 2. So that we can say that the length AB in triangle OAB is equal to r by tan theta by 2. Now, if we look at quadrilateral OCED, then we can see that angle OCE plus angle ODE plus angle CED plus angle COD is equal to 360 degree. And as we can see from this picture that angle OCE is equal to 90 degree and angle ODE is also equal to 90 degree, and angle CED is equal to 180 minus theta, and let the angle COD is equal to x, and the sum of all these angle is equal to 360 degree, so that the angle COD must be equal to theta. Again, from the geometry of this picture, we also can say that the triangle OCE is congruent with triangle ODE. That is, angle EOD is equal to angle COE. This is equal to half of the angle COD. This is equal to theta by 2. So we can say that the length CE is equal to r into tan theta by 2. Now, since the system is in equilibrium, so the net torque would be 0 for each stick. Now, in case of stick 2, since the net torque would be 0, so it can be said that The torque generated by the contact force N3 must be compensated by the torque generated by the contact force N2 and the torque generated by the weight of the stick 1 which has an effect on stick 2. This can be written as in equation form, that is N3 into R by tan theta by 2 minus N2 into R into tan theta by 2 minus mg cos theta into 1 by 2 into R by tan theta by 2 is equal to 0. If we take the common factor, that is R by tan theta by 2 from this equation, then the equation can be written as N2 into tan square theta by 2 plus mg cos theta by 2 is equal to N3. By symmetry, we can write this equation in general term as Ni into tan square theta by 2 plus mg cos theta by 2 is equal to Ni plus 1. This is our equation 1. Now, the real concept behind this problem is, when we go to the right toward the wall, there would be a reduction in torque with each successive sticks. But as we know that the system is in equilibrium, so the reduced torque is compensated by the wall. So in this case, very far to the right, it can be said that the contact force, that is Ni, is approximately equal to the contact force, that is Ni plus 1, and both are equal to N infinity. It is assumed that the ith term is at infinity. So from equation 1, it can be written in terms of N infinity as both Ni and Ni plus 1 can be replaced by the term N infinity. So the equation can be written as N infinity into tan square theta by 2 plus half into mg cos theta is equal to N infinity. N infinity minus N infinity into tan square theta by 2 is equal to half into mg cos theta. That is N infinity is equal to mg cos theta divided 2 into 1 minus tan square theta by 2. Now, if we put the value of m, that is mass of the stick, this is equal to rho into r by tan theta by 2, then the N infinity would be rho into r into g divided 2 into tan theta by 2 into cos theta by 1 minus tan square theta by 2. Now we put the value of cos theta from the trigonometric identity or formula, then we can put cos square theta by 2 minus sin square theta by 2 in place of cos theta, and sin square theta by 2 divided cos square theta by 2 in place of tan square theta by 2. Now then N infinity would be rho into r into cos square theta by 2 minus sin square theta by 2 into g divided 2 tan theta by 2 into 1 minus sin square theta by 2 divided cos square theta by 2. And after solving it, we get our answer, that is N infinity is equal to rho into r into g into cos q theta by 2 divided 2 sin theta by 2. This is the solution of our problem.